Welcome to the General Knowledge Test Prep for Math. Let's get started. Okay, the General Knowledge Test is designed to test you over 4 major competencies, which are divided into several subsections each. Today we'll be going over the math section. The test is going to consist of 45 multiple choice questions, and you are given 100 minutes to complete it. And just to note, it is the last section of the exam. There is a calculator built into the program. But when I was able to take it, they did let me use a handheld calculator. I doubt they'll let you bring one, but you should always ask if they have one that you can use. When you schedule your exam, be aware of when your start time is and how long the test will take. The test will take 275 minutes. You may finish a section a little earlier than the time allotted, but as soon as you finish that section, the test will automatically go into that next section. And after the second section, there will be an automatic 15-minute break, and the timer will start to tick down as soon as you finish that second section. So like I said before, the math section is the last part of the exam. And 275 minutes, or by then 175 minutes will have gone by. That's a long time. That's almost 3 hours. Your brain's going to be tired. You're going to be ready to quit. You're going to be ready to just, maybe not put as much effort into some of those final problems, but you got to stick with it, power through it. You don't want to, rush and miss a question that if you'd spent a little more time on, you probably could have gotten right. All right, so this is the breakdown that the publisher posts on their website. Like I said, from my firsthand experience, I would say that this is pretty accurate. So if there's a section that you aren't as familiar with, I know for a lot of people that's going to be statistics. Well, that's the largest section of the test. So just be prepared and follow. Some of the questions that we're going to go over are going to be statistics and probability type questions. And I highly recommend, if there's a type of problem that you don't like, get with us and we'll help you. We can get plenty more examples of that particular type of problem. Here's a couple tips for watching this presentation. Pause the video before the explanation and try it on your own first. That way you'll know for yourself whether you may have an idea of how to solve it, you may not have an idea how to solve it, or you know exactly how to solve it. Make a note of the particularly troublesome problems. That way you can email us. The email is listed at the very end of this video, or you can join us in a live chat. We're also going to send out an email with a link that'll give you access to our live question and answer for this presentation, as well as all of the other general knowledge test presentation that we are giving.
Okay, so to find the percentage that was taken off the original, what I'm going to do first is just find out how much was taken off, what the actual discount was. So I'm just going to subtract the sale price from the original price, and this is going to give us $4.80. So anytime you need to find a percentage, think of it as a fraction with the numerator being the is and the denominator being the of. So it's going to be is over of. And so our discount was $4.80. And I'm just going to divide that by the original because we're comparing it to the original. And in the calculator, this is going to become 0.2. So to make that a percentage, we just need to move the decimal place 2 times, 1, 2. And so this is going to equal 20%.
This one gives you a simple interest formula of I equals PRT. The I is the interest. It's the actual amount of money that's earned in interest. P would stand for your principal. That's the amount of money that you actually are putting into the bank. In this case, that's going to be the $500. R is the rate that it's paying. In this case, it's 5%. And T stands for time. And it's, in almost every case, probably anything you're going to deal with, it's going to be in number of years. So if you write out the formula, and this is the method that I like to use, PRT, that way I've got it in front of me. I believe you'll be given this formula on the worksheets, but you can't be certain of it, but you want to make sure you know that. We know we're trying to find the amount of interest, and the amount of interest is going to be in money, right? It's going to be money. We can look at the answers to see that that's all the answers are in the form of money, so that's what we're looking for. So the method that I like to use is to take these variables and pull them out and just leave empty boxes there that I'm labeling so I know what goes in there. So we've got a box for principal, one for rate, and one for time. And I'm just labeling them so I know what goes in there. We know the principal, the amount of money that's invested is 500. We know the rate is 5%, but it's given to us in a percentage. We need to convert that to a decimal. So the way you do that is you're just going to move the decimal place over, right? This is where the decimal is right now. You're going to move it 2 places to the left. So you're going to wind up with 0.05. 0.05. Be careful that you don't put it as 0.5 because that would be 50% interest and that'd be way too much. And time in this case is 4. So once you have that, if you just put that into your calculator, 500 times 0.05 times 4, and that gives you $100. And the answer then is C. You can see that these other answers, particularly A and B, seem perhaps unreasonable to turn, to double your money or to have $10,000. So some of those you could have eliminated from the start.
How many whole numbers leave a remainder of 2 when divided into 30 and leave a remainder of 4 when divided into 32? So first we need to recall a little bit of basic arithmetic and think of how we do long division. And there is a little reminder of how that works in the PowerPoint presentation. So we get our remainders from subtracting. So we want to think of a number what we could subtract from 30 that would leave 2. And clearly that would be 28. So I know that if I divided 28 into 30, it goes 1 time. 1 times 28 is 28. And I subtract that and I get a remainder of 2. So 28 is going to be one of those numbers that divides into 30 with a remainder of 2. What's going to happen is all of the factors of 28 are going to kind of become our suspects. Now, 1 times 28 will give us 28, but 1 will never have a remainder when you divide it. Every number is divisible by 1. So we also have 2 times 14, and then we have 4 times 7. So those are all the factors of 28. We know that 28 leaves a remainder. We can immediately, like we said, cross out the 1. It's not going to have a remainder. 2, if we divide 2 into 30, it goes 15 times with a remainder of 0. So we can cross the 2 out. 4 is going to go into 30 7 times. And there's the 28 again. That's what we want to happen. And it leaves a remainder of 2. So 4 is going to work. And then just by inspection, we know that the 7 is going to work the same way if we just replace the 4 with the 7. And so we can go on and try 14. It's going to go 2 times. There's the 28 that we want with a remainder of 2. So those are our 4 numbers that we're going to be able to choose from to divide into 32 and leave a remainder of 4. One thing you want to just keep in mind, kind of like what happened here with the with the 2 is that since it evenly divides 30, there's the remainder of 0. 2 is a factor of 30. So any factors of the number we're dividing into will always leave a remainder of 0. So if we tried 4 into 32, it goes 8 times, right? With a remainder of 0, since 4 is a factor of 32. So we can eliminate the 4. 7 is not a factor of 32. 14 is not a factor of 32. 28 is not a factor of 32. So all those numbers, if we divided into 32, 28 goes 1 time, and it leaves a remainder of 4. 14 is going to go 2 times and give us that 28, and then 28 is the number that we're going to subtract from 32, and we're always going to get a 4. So if I did 7, it goes 4 times with a remainder of 4. So 28, 14, and 7 are going to be the only whole numbers that we can divide into 30 with a remainder of 2, and divide into 32 with a remainder of 4.
This problem involves order of operations. Many of you learned it as PEMDAS, or I learned it as please excuse my dear Aunt Sally. P, of course, stands for parentheses. So you're going to do anything inside parentheses first. E stands for exponent. So you're going to deal with the exponents next. M and D is multiplication and division. You're going to treat those as equals. So if you are working and you have multiplication and division and you've dealt with everything to the left of this, you're going to work on your multiplication and division left to right, just like you're reading. The same thing is true of addition and subtraction. You're going to treat those as equal, and if you come across just addition and subtraction, you're going to do those left to right. So let's do that as a practical matter. We've got a problem here, and we see multiple sets of parentheses. You always want to work from the innermost parentheses first. Always work from the innermost parentheses first. And in some problems, you might see the first set of parentheses look like that, and then some folks will treat the next outer ones as brackets, and then out from that would be these braces. That's not always the case. Sometimes you just have parentheses like that, but I wanted you to recognize those as well as another way to organize these. So I'm going to rewrite the problem, copy it over here, and we're going to work from the innermost to the outermost. So we got this set of parentheses, and then we have this innermost ones. So I'm going to work the innermost ones first. I have 5 minus 8. So if I've got 5 and I take away 8, then I'm left with a negative 3. Negative 3. So I'm going to rewrite everything else above it and bring it all down to do the next step. I like to do these a step at a time. So now there's nothing else I can do with this innermost parentheses. So I look at the next set of parentheses. I'm going to ignore everything outside of the parentheses at the moment. So I've got 2 choices here. I have addition, which is 4 plus 3, and then I've got this 3 that's right next to the parentheses. When something's right next to the parentheses like that, that means it's multiplication. So between addition or multiplication, our Aunt Sally says we need to do the multiplication first. So I've got a 3 times a negative 3. When you're multiplying and you've got 2 opposite signs, the result is always going to be a negative. If you're multiplying 2 opposite signs, you're going to an answer that is negative. If you're multiplying two signs that are the same, you're going to get a positive result. So if you multiply two negatives times each other, you get a positive result. Just keep those in mind and get used to that, because some of these problems will get more involved with the signs. You don't want to mess that up. So I've got a positive 3 times a negative 3. The signs are opposite, so my answer is going to be a negative. 3 times 3 is 9. So I've got that, and over here I'm going to bring everything else down. 4 plus and negative 2. Well, if I'm adding a negative, that's really the same thing as subtracting. So I'm just going to rewrite that as 4 minus 9. So I didn't change anything, I'm just adding a negative, which is the same thing as subtracting. So I've got 4, and I take away 9, that gives me a negative 5. And over here, I've still got the negative 2. There's nothing else to do inside the parentheses. The only thing left is the negative 2, and remember, it's right next to it, so it's a multiplication. So I've got a negative times a negative, so my answer I know is going to be positive. 2 times 5 is 10. The answer is positive 10.
So our goal is to put these numbers in order from least to greatest. So if we can make them all look the same, it's going to be a lot easier. So the best way to do this is just put them in the calculator and turn them into decimals. So our first one, 1 divided by 6 is going to be about 1 or 0.16 repeating. 17% as a decimal, we just need to move our decimal place 2 times to the left, so that becomes 0.17. The square root of 0.1, this is another problem that we just want to trust the calculator, because it's going to be way too hard to try to figure this number out by ourselves. And this is going to be about 0.316. And the last one's already a decimal, so we're good there. So from least to greatest, that would be the least, then the next, then the next, and then the next.
This next problem is another one of these word problems or practical problems where we've got to kind of figure out from the words what the mathematical formula is or equation we're going to use, and then from there solve it. This one says an aircraft carrier has made its trip to Guam and back. So we'll just call this place home. I like to kind of do a little quick drawing. And it went to Guam, and then it came back. So drawing as simple as that might just help you visualize this a little better. The trip there took 3 hours, and the trip back took 4 hours. The average speed on the return home was 6 kilometers per hour. So you want to find the average speed on the trip there. Well, we need to use one of the formulas that you are given, and that is distance is equals to rate times time. D equals RT. Rate is the same thing as the speed. So distance equals rate times time. You'll be given that formula in the formula sheet, but it's a good one to know anyway. So we're going to plug in the information that we have into this formula. But the thing that we don't know is the distance, right? We don't know the distance. We do know a rate and we do know a time for one of the directions, but not for the other one. Here's the trick for doing a problem like this. What we do know is that the distance from home to Guam is exactly the same as the distance from Guam back to home, right? Unless the island moved, the distance there has got to equal the distance home. So we can start from that premise. Distance there is equal to distance home. Now, since we know that distance equals rate times time, I can just plug in for my distance there, I can plug in my rate there and my time to get there. I'm just doing a little sub so I know what I'm talking about there on that. And that is equal to, and on this side, again, the distance is equal to rate times time, so I can just substitute in, and I'm going to use empty boxes, the rate home times the rate, or times the time home. So there's multiplication here, multiplication there. They're going to be equal. All I did was substitute the RT for the D. They're the same. If you were to have a $5 bill and 5 singles, they're the same value even though they don't look the same. All right, so you've got this. We have some information here we can plug in. All right, the time to get to Guam is 3 hours, so I'm just going to put a 3 there. The rate home, we're told, is 6 kilometers per hour. The time home is 4. And the only thing we don't have is the rate there. So I'm just going to leave that as an R, right? Or you could make it an X or whatever you want to do it. That's your variable. That's what you're going to solve for. And that, whatever you're solving for, is going to give you your answer up here. So I'm going to multiply this out. 3 times R is going to be 3R. And I can use the little sub t just so I can remember that what we're dealing with is the rate there, is equal to 6 times 4, of course, is 24. So I've got 3 times R on this side. I want to get the RT by itself, so I'm going to divide both sides by 3. Whatever I do to one side, I do the exact same thing to the other. The 3 over 3 becomes a 1. My rate there is equal to 24 divided by 3 is 8, and my units are kilometers per hour. So that means C is the correct answer.
Okay, 9 pounds of mixed nuts containing 55% peanuts were mixed with 6 pounds of another kind of mixed nuts that contains 40% peanuts. What percent of the new mixture is peanuts? So we're going to do a couple things here. The first thing I'm going to do is find out how much of the 9 pounds is just peanuts. So if we know 55% of 9 pounds, so I'm going to convert that percentage into a decimal, so 0.55 times 9. And this gives me 4.95. And the other mixture, we had 6 pounds, and it's 40% peanuts, so 0.4 times 6 gives me 2.4. So I know that combined 4.95 plus 2.4 is going to give me 7.35. So I'm just adding those together. And that's the total amount of peanuts combined in the 2 mixtures. Well, we also know that the first batch was 9 pounds, the second batch was 6 pounds. So 6 plus 9 gives me 15. So I know that we have a total of 15 pounds of mixed nuts. And we know that combined, only 7.35 pounds are going to be peanuts. So if we take the 7.35 divided by 15, this is going to give us 0.49. So that tells us we're going to have 49% peanuts.
In this problem, you're asked to find the slope of a given line. In this case, it's this blue line here on the grid. Slope is talking about how quickly a line is going up or going down as it's going through the graph. The best way to do this is always read the graph left to right. Read the graph left to right. So if you're going left to right, is the line going down? If the line is going down, that is a negative slope. If your line was going up as you're going left to right, that would be a positive slope. If the line were exactly horizontal as you're going left to right, that would be zero slope. And then if the line were perfectly vertical, that would be undefined. Undefined slope. So those are your four possibilities. As it's going down, that's negative, going up, positive. Horizontal would be zero slope, and then straight up and down, vertical would be undefined slope. So I always recommend to students, when you first look at the graph, go ahead and determine which of these four possibilities it is, and just kind of jot that down. And in this case, it's going down, so that's a negative slope. So the reason I tell you to do that is because, number one, we can now eliminate from the answers any of the possibilities that have a positive slope. So we can just get rid of those. So now we're left with a 50-50 chance. So if you were running out of time on the test, you could just go ahead and eliminate those two, and if you had to, choose one of those two. Now I want to show you how to do it so you don't have to guess, but that is a strategy. It's also a way of checking yourself, because if you go through this and wind up with a positive slope, you'll know that you did something wrong, and you can go back and check yourself. All right, as I mentioned, the slope is talking about how quickly the line is going up and down, or down. And there is a formula you'll be given for slope, but we're going to do this just visually. Slope, which is oftentimes abbreviated as M, is equal to the rise over the run. And to help folks remember, I always tell people you're reading left to right, so you're going to run left to right. And I tell students always rise up. Now obviously if you're going down, you're not rising up, so that's going to tell you it's a negative. So it's just a quick, easy way to remember that. So we're going to look at how far we're going from one point to the other, if we're going up or down, and how far. So let's figure out first the run. And you're going to pick 2 points on the line. Any 2 points on a straight line are going to have the same slope. In this case, they've selected points for you, which is good. But if they hadn't, you're going to want to select points that are easy to figure out. If you were to select a point here, for example, that's between the boxes, you can't really figure out what that one is. So I do ones where the grid crosses. So we start at this point, because we're going to read left to right, and we're going to that point. Let's see how far left we go first. So that point is, if I go straight up, is to here, right? So I'm going to go from here, and I'm going to 1, 2, 3, 4. All right, 4. 1, 2, 3, 4. So I ran 4. So that's my denominator in this case. Let's look at how far from here, which is the same level here, all the way down to here. It's going to be 1, 2, 3, 4, 5. And so I put the 5 there, and since we went down, the memory trick is to rise up. Since we're going down, we're going to have a negative. So negative 5/4. Negative 5/4 is the correct answer then.
Okay, let's solve this compound inequality. And a compound inequality is just going to be an inequality that has two inequality symbols in it. So essentially we solve this the exact same way we would solve it if we only had one inequality. Just think of it, instead of just a left and a right, we have a left, a center, and a right. So whatever we do in the middle, we have to do on both sides. And so what we want to do with solving an equation or inequality is we want to get that variable by itself. So we can subtract 9 everywhere. So negative 1 minus 9 is going to give me negative 10. Is less than n is less than 8. And that's all there is to it.
In this problem, we're solving for n. In other words, we want to get the n by itself. I'm going to rewrite the problem here, just copy it over just to have something to work from. And we notice here that there is more than one n. So we need to get everything combined together. All right, so since we have fractions on both sides, you could do something that a lot of students like to do, and that is cross multiply, right? So on this side, we have 5 times n is 5n. And on this side, I've got n plus 1 times 3. I'm going to keep them separate for a moment. All right, so it's going to look like that, correct? All right, so on this side, I've got 5n. On this side, I've got 3 times, parentheses, n plus 1. Since I've got a parentheses here, there's nothing I can do inside it because I don't know what n is, but I can distribute the 3. That means I'm going to multiply it by each of those terms. That's a binomial. So 3 times n is 3n, and 3 times 1 is positive 3. So get 5n is equal to 3n plus 3. I want to get the n's together, so I can move this 3n this way or the 5n this way. I'm going to move it this way so I wind up with a positive n. So I'm going to subtract 3n from both sides. So you got 5n minus 3n is 2n. 3n minus 3n is 0. And I just bring down the positive 3. I want to get the n by itself. The relationship between the 2 and the n is multiplication, so I do the opposite. I divide by 2, and if I do that to one side, I have to do it to the other. 2 divided by 2 is 1, so I've got n is equal to 3 halves, which is b.
Okay, we have a conversion problem. We need to convert our pesos into dollars, and we have this exchange rate that's given to us. So the one thing you want to do with these types of problems is just make sure you're consistent in the way that you set it up. And the way I'm going to set this up is a proportion, and I'm going to do dollars over pesos. And as long as my fraction over here is the same, then we're going to have equality and we'll be able to solve it. So since we're solving for dollars and we're putting dollars over pesos, I'm letting X represent our unknown amount of dollars. And there we go, we have a proportion. So to solve proportions, we just cross multiply and then we'll divide. So we have 19.1x equals 427, and then we divide 19.1. So x here is going to be 22.356 something, something, something. And so I just went out a third decimal place because we're going to round it to 2 since we're working with money. So since the 6 is more than 5, this gets rounded up to 22.36.
This is another one where we are using a word problem to solve this. So we've got what temperature is the same number for Fahrenheit and for Celsius. Of course, the C stands for Celsius, the F stands for Fahrenheit. In other words, where does C equal F? And we could take this formula, and I'm going to rewrite it. And we could do some algebraic manipulation of it and try and set them up equally to each other. But in this case, because you're given four possible answers there, I think it's best to just go ahead and plug those answers in to the formula to see which one actually equals Fahrenheit equals Celsius. So I'm going to use my usual strategy, and I'm going to take the variables out, leave empty boxes there, and label the boxes, and go ahead and rewrite the formula that way, like that. And that way I've got a nice clean formula there that I can use. I can start plugging in the numbers. So I'm going to use a different colored pen here to do that. Let's try the first one, A, which is 0. So we want to see where is Celsius. Is Celsius equal 0? If Celsius is equal to 0, is Fahrenheit going to be 0? So we're going to plug the 0 in for both of those, right? You're going to plug them in for both. So on the left side, I've got 0. And on the right side, of course, my dear Aunt Sally tells me I've got to do what's in the parentheses first. I've got 0, and I subtract 32 from it. I've got negative 32. And I'm going to take my negative 32 and multiply it by 5/9. But I really don't have to do that, do I? Because there's nothing, this is not going to wind up being 0, right? It's going to be some number. I can use the calculator and multiply it out, but it's not going to equal 0. So I can stop at that point and not waste any more time, and I can cross out A. I can do the same thing now for B. So B, it tells me to plug in 32. So 5/9, my Fahrenheit, 32, plug that in, minus 32. So on B, we're going to take what's inside the parentheses first, 32, and I'm going to subtract 32 from it. 32 minus 32 is 0. So I've got 0 in the parentheses. 5/9 is equal to 32, right? I'm going to multiply the 0 times 5/9. Well, 0 times 5/9 is going to be 0, isn't it? Anything times 0 is 0. Does 32 equal 0? Of course not. So we can cross that one out. So let's try the next one. And if you're given a dry erase board to work on to solve these problems, you can just write the equation once and then keep filling it in. So I'm going to put a negative 40 for Celsius. And mind you, I'm putting the same number in for Celsius and Fahrenheit here. All right, I'm going to work the inside parentheses first, negative 40, and I take away 32 more. That's negative 72. All right, and then this part could be just some calculator work, right? If I've got a negative 72, right? So I've got a 72. I'm going to multiply it by 5, right? Multiply it by the numerator. And then I'm going to divide it by the 9. And guess what? I've got negative 40. Negative 40 is equal to negative 40. So my answer is C. I don't even have to spend time doing D.
Okay, we need to find the next number in this sequence. And so the two types of sequences that are most common are going to be either an arithmetic sequence or a geometric sequence. The arithmetic sequence is going to be when the next number in line is found by either adding or subtracting the exact same thing each time. So we can look at this problem and tell that the numbers are getting smaller, but they're not getting smaller by the exact same number. So 54 minus 18 gives me 36, but 18 minus 6 is not 36. Right, so we know that it's decreasing, but it's not decreasing by the exact same amount. So it's more likely going to be a geometric sequence, which is going to be where you're multiplying or dividing by the same number each time. And so what we can do here is just take consecutive numbers. 54 divided by 18 is going to give me 3. 18 divided by 6 also gives me 3. And then just to finish it off, 6 divided by 2 is also going to give me a 3. So these numbers are being divided by 3 each time to get the following number. It's a common ratio is what we call that. And so all we need to do to find the next number would just be 2 divided by 3. And since it doesn't reduce as a fraction, that is going to be the next number in the sequence.
In this problem, we're going to be determining which of the following graphs, and there's 4 graphs here, represents a function. You will not need a calculator for this one. You can just do it with your pen, and I'll show you how. We need to understand what a function is. What a function is defined as, you want to write this down, that for every x, there is only one y. So for every x that you have, if there's an x, there can be only one y. If you have more than one y for the x, it is not a function. So if you had, x and y, and your x, say, was 2, and your y is -3, and then you had another one where the x is 2 and the y is 5, well, that would not be a function because your x of 2 has a -3 and a 5. So that would not be a function. So you can look at it that way, or we can do what's called the vertical line test. The vertical line test is, like I said, you can use your pen and lay it down or put it on the screen and put it vertically, and you're going to see, does the graph, in this case it's the red line is the graph, the line in the graph, and does it cross your vertical line more than once? So I'm going to take my pen here and run it across this one, right? And yes, it's touching both on the top here and the bottom, right? My vertical line, it's touching twice. And since my graph is touching twice, in other words, there's a y up here and a y down here. Here's the x, for example, -4. There's a y here and a y here. W is not a function, so we can cross that one out. Let's try this x one. All right, so far so good, looking good, only one y for the x. And then we keep moving it this way, and then when we get to this point in the line, it's kind of covering it. Say, let's look at the origin here. At the y-axis, there's a y here, there's a y here, and there's a y here. So that's more than one y for the x of 0. So this one, b, is not a function either. Let's look at y, this one here, y, and I'm going here with my line, and I get to my vertical line. Well, my graph is a vertical line, so there's an infinite number of y's for the x, right? An infinite number. That's way more than one. So this one can't be it. By process of elimination, it looks like it's z, but let's check it anyway. So I'm going to run my vertical pen across, and I'm only touching it once, only touching it once, only touching the red line once, only once as we go across, right? So there is only one y for each x. So z is the correct answer.
Okay, Cosmo's taking a trip from his house to the airport. If he drives 60 miles per hour, then he'll arrive 1 hour early. And if he drives 30 miles per hour, he's going to arrive 1 hour late. What is the distance from the house to the airport? Okay, so one way I like to do this is think about if we're supposed to get there at 4 o'clock and we're arrived 1 hour early, then we would just do, okay, well 4 minus 1 gives me 3, then I would arrive at 3 o'clock. Right, so I'm just subtracting 1 from whatever time that I'm supposed to be there. It doesn't really matter. And similarly, if I was supposed to arrive there at 4 and I arrived 1 hour late, then I would just add 1 hour to the time that I was supposed to be there. Since we don't know, and it doesn't really matter what time that we were supposed to be there, we're just gonna let our time equal X for now. And so we know that distance equals rate times time, and this is one of the formulas that is on the reference sheet. And so we know that our rate when we get there 1 hour early was 60. And we said that if we arrived 1 hour early, that would just be subtracting 1 from our time that we were supposed to be there. Similarly, we know that 30 miles an hour is going to be multiplied by x plus 1 because that is going to get us there an hour late. Well, the distance doesn't change based on our speed, so we know that these two distances are equal to each other, and we have an equation that we can solve. Okay, so I'm just going to distribute. This gives us 60x minus 60, and this gives us 30x plus 30. I'm going to get my x's together, so I'm going to subtract this 30x from this side over here. And then while I'm at it, I'm going to add 60 to get my constants together. So 60x minus 30x gives me 30x. 30 plus 60 is 90. Divide by 30. And we get that x is equal to 3. Well, this is just our time, right? And so the problem's asking for the distance. Well, this is a distance and this is a distance. So it shouldn't matter which one I plug it in. So what I'm going to do is say, okay, well, 60 times 3 minus 1, which is 2, gives me 120. And just to be sure, if I plugged it in here, 3 plus 1 is 4, 30 times 4 is also 120. So 120 miles is how far away he lives from the airport.
This problem involves scientific notation. Scientific notation is used for very large or very small numbers. It's usually in the format of some digit, a decimal place, 1 or 2, maybe 3 spaces, 3 more digits, multiplied by 10 to some exponent. All right, to some exponent. Now, let's think about our exponents for a second. If this is a positive exponent, for example, let's say it's 10 to the third. This is not telling you 10 times 3. This is telling you multiply 10 by itself 3 times. Right? 10 times 10 times 10 is going to be 1,000. So if it's a positive exponent, it's showing you it's going to be a very, very large number. Right? It's going to be a large number. If it's a negative exponent, let's say 10 to the negative 3. When you've got a negative exponent, you take whatever your base is. In this case, 10 is our base. That's the number that the power or the exponent is raising. And you put it in the denominator. So it becomes 1 over 10 to the positive 3. Then when it's in the denominator, it becomes positive. So this is the same thing as saying 1 over 10 times 10 times 10, which is the same thing as 1 over 1,000. So 1,000th is what that becomes. So if it's a negative exponent, then it's a very small number, right? So let's keep that in mind as we're working with these. The other thing that, and that is irrespective of what the actual sign is in front of this. In front of the number, you have a positive or a negative, which just indicates whether if it's negative, right, it's going to be to the left of the 0, right? You got a 0 on the number line. All your negative numbers are to the left of the 0. So if you got a negative here in front, it's going to be to the left of the number line. If you've got a positive number here in front, it's going to be to the right of the 0, and it's going to be a positive number. Okay, so far so good? So we're looking for a number that falls between 0 and 2. 0 and 2. All right, what do we know about the numbers between 0 and 2? If I put the 2 on the number line here, and we're saying the numbers between 0 and 2, we're talking about positive numbers, aren't we? So we're going to be working with positive numbers. What does that do for our choices? Well, we've got 4 choices here, and 2 of them have negatives in front of it. Well, those would be to the left of the number line, or left of the 0 on the number line. Those cannot be the answers. So right from the start, we've eliminated 2 of the possibilities and have 50-50 shot. Okay? We want you to work through everything, but if you're running out of time, strategies like that will help you. It will also help you realize if you're doing something wrong, you may wind up with the wrong answer. All right, so let's look at B. B is 4.037 times 10 to the second power. Well, I could just multiply the 10 times 10 to get 100, multiply 100 times that. And that's easy enough to do with small numbers, but if this large number, if your exponent becomes something really big, then that becomes very cumbersome. So all we really need to do is take this exponent and we're going to move the decimal place to the right that number of places. Because it's a positive, we're moving it to the right because it's going to be a larger number. Right? So our decimal place is here. We got to move it to the right 2 places. 1, 2. So this is 403.7 is what that number actually is. All right? Well, is 403.7 between 0 and 2? No. So we can cross out that one. So by process of elimination, it's likely going to be D, but let's check it just so we know the process. Now, we have a negative exponent up here. So that tells us we're going to be dealing with a very small number, right? A small number. And it also has nothing to do with whether it's to the left or the right on the number line, because you can have small numbers that are positive, right? You can have very small positive numbers, just like you get very small or very large negative numbers. So we're just looking at this. So since we know it's going to be a small number and it's got a negative, we're going to move the decimal place to the left that many places. So I got 4.037, and I'm going to move the decimal place to the left 3 times. 1, 2, 3. So I've got a 0 here, and for all these I'm going to put a 0. So it's 0.004037, which is a small number. Is this number between 0 and 2? Yes, it is. It's not even quite 1. It's above 0, though, so it is a positive number. So D is the correct answer.
Okay, number 17 is just going to be more or less a review of some algebra. So when we have 4 raised to the 3rd power, that means 4 times 4 times 4. We're multiplying the base times itself 3 times, and this gives me 64. So 3 to the 4th power would be 3 times 3 times 3 times 3. And if we throw that in the calculator, we're going to find that is 81. 64 is not equal to 81, so we know A is not the right answer. B, we have 5 to the 0. So any number raised to the 0 power, except for 0, is always going to give us 1. Okay, so that tells us that we have 1 times 8 squared. 8 squared is 64. So 1 times 64 is 64. So on my left-hand side, I have 64. And then we need to find out what is 2 raised to the 6th power. So 2 times 2 times 2 times 2 times 2 times 2, that is going to give us 64. So we do have a true statement in B. So in C and D, the reason why those are there, I think it may be to maybe trip some people up that are confusing those rules with the multiplication rule. So if your bases are the same and you're multiplying those numbers together, then we would add the bases. You're probably not going to be able to put a number that big into your calculator. That like 5 to the 10th power is going to be a massive number. So I think that is probably the reason why those choices are there, to just maybe trip people up on the, like I said, about the rules for multiplication.
In this problem, we're asked to simplify, and we're not solving it because there's no equal sign to solve. All we need to do to get it into its simplest form. There's a couple rules that may be helpful for you. The first one would be the product rule. The product rule tells you if you've got something such as a to the m multiplied by a to the n, it's going to be equal to a to the m plus n. A key thing about this is, for the product rule to work, you have to have the base the same. So the base is what's raised to the power. In this case, a is the base, m is the power. In this case, a is the base, n is the power. Since we have the same base, all we need to do is copy over the base and then add the powers. That's the product rule. We also need to know that if you've got a negative exponent, such as a to the negative m, that's the same thing as saying 1 over a to the positive m. So it just inverts it like that. So it puts it in the denominator, and then it makes it positive for the exponent. Another thing you might need to know would be the power of a power rule, which tells you if you've got something such as a to the m and the whole thing is raised to the n, such as that, then all you do is copy over the base again, and you're going to multiply the exponents. So in this case, because the entire thing inside the parentheses is raised to the n power, we're going to multiply the exponents. And one more rule that will help you is if you've got a 0 exponent, a to the 0, anything to the 0 is going to be equal to 1. All right, with those rules, let's tackle this problem. I'm going to rewrite it. A cubed b squared, parentheses, a to the 5th b, parentheses, close parentheses, all raised to the negative 2 power. Another thing I want to point out here is there's no addition or subtraction. This is all multiplication. Everything's multiplied, which means you can rearrange it any way you want to, right? If 2 times 3 is the same exact thing as 3 times 2. So when you've got multiplication, you can just rearrange everything any way you want to. So with that in mind, let's see what we can do with this. All right, I've got some parentheses here. So that tells me that I want to look at this power of power rule, because everything inside here is raised to the negative 2, right? Everything is raised to a negative 2. So let's deal with that. So I'm just going to rewrite the first part here, a cubed b squared, and then just rewrite this. I've got a to the 5th power multiplied by -2. And then that's multiplied by b, and you don't see an exponent there, but there's an invisible 1. Anytime you don't see an exponent, there's an invisible 1 there. We're going to take the -1 and we're going to multiply it by we're going to take the +1 and multiply it by -2. All right, so all I've done is kind of distributed this -2 exponent in there to multiply it using the power of the power rule. So I'm just going to rewrite the beginning here, a cubed b squared, and then I've got a, just copy that over, a, and 5 times -2. If I've got a positive times a negative, it's a negative, and 2 times 5 is 10. So I get -10 there. And then on this one, I've got a 1 times a -2. So I got b to the -2 power. I don't really need the parentheses anymore because I've gone ahead and dealt with it using the power of the power rule. The next step, the next thing you want to do is I'm going to take this and I'm going to rewrite it by grouping things that are similar. So I'm going to take the bases that are the same and group them together. So I'm going to put a cubed, that's this one, times a to the -10, that's that one. That took care of the a bases. And everything is multiplication, so I'm just going to have another parentheses here, just to group. There's the only reason to the parentheses, I'm just grouping things together. I've got b squared, that's that one, and then multiplied by b to the -2. The parentheses are just helping me get like bases together. The reason I'm doing that is because I'm now going to apply the product rule, which tells you that the bases have to be the same. So in this case, I've got a and a. So, and they're multiplied together, so I'm just going to copy over the base, and then I'm going to add the exponents. 3 plus, and I'll put it in parentheses just to keep it separate, -10, just so you don't lose the negative in front of it. 3 plus -10. And then over here, I've got bases of b and b, so I'm going to copy over the base, and I'm going to and I'm going to add the exponents, 2 plus, and I've got a parentheses to protect my -2 there. All right, I don't really need the parentheses anymore on the outside because these are just multiplied by each other. So if I'm adding a negative, that's the same thing as subtracting. Adding a negative is the same thing as subtracting. So I've got a, 3 plus a -10, in other words, 3 minus 10 is -7. And I'm multiplying that by, I've got b, and I've got 2 plus a -2. And again, adding a negative is the same thing as subtracting. 2 minus 2 is 0. So you got a to the -7 times b to the 0. Anything to the 0 power is 1. So this equals a to the -7 times 1, which is just itself, right? That's just a to the -7. Well, if I look over here, I don't see a to the -7 anywhere. I see a to the +7, but not a to the -7. But we know from this rule here that it's the same thing. A to the -7 is the same thing as saying 1 over a to the +7, which is a.
Okay, so our next problem is an absolute value problem, and just as a little review, this is the definition for absolute value. If what we're taking the absolute value of is positive, then we just drop the bars. If whatever in here is negative, then we have to change the sign. So we don't know if 3x minus 5 is positive or negative, so we can't just immediately pick one of these options. We're gonna have to do both of them. So it's kind of a buy one, get one free. So the first thing we do with solving absolute value problems is isolate the absolute value thing. get it all by itself. So I need to get rid of this 10. So I'm just going to subtract it over to the other side. Now that we've isolated our absolute value, this is where we're going to set up two equations. So the first one, we're just going to assume whatever's in there is positive, and so that just becomes 3x minus 5 equals 20. But then we also have to consider that maybe what is in here is negative, and so we need to change the sign of it. And the easy way to do this is just change the sign of what we have it equal to. So I'm going to drop the bars, 3x minus 5, and now I'm going to say it's equal to negative 20. And so we have these two problems that we need to solve. And the steps should be identical to both of these. Divide by 3. So I get that x is equal to 25/3. And then, like we did here, I needed to add 5. I still need to add 5. This gives negative 15. Divide by 3. X is going to be negative 5. So both of these are the answers. They both will make our original problem true.
In this problem, we're solving for x. Now, there's more than one way to tackle problems like this, and we could use several different methods. We could use the quadratic formula. We could use a couple different things to solve for x. But to save time on this particular problem, you're given the answers. Most likely, the quickest way to answer this one would be to just plug in the answers and see which ones actually work. So I've got x squared minus 2x minus 15 is equal to 0. We're just going to plug in answers and see which ones are actually true. In other words, we're solving for x. What values for x make this true? And because it's a squared value, in other words, this is a quadratic, it's raised to the second power, we're going to usually expect two answers. So, and that's why there's each of these, except for this one, have two answers, negative 3 and 5, 2 and 0 and 2, 3 and 5. There's more than one answer that will solve it. So let's see what we can come up with. I'm going to go ahead and pull out the variable and leave it an empty box there, and I'm going to label it. So that's an x goes in there. I've got a 2. I've got an x goes in there. And I've got a minus 15 is equal to 0, right? So let's start trying these values. Let's start with the 3. Now, we have to plug in the same number for each of the x's. I can't just choose one of the x's to do it to, and I can't just use the 3 in one of them and negative 5 in another. I have to choose the same number for each. So if I plug a 3 in here, I have to plug a 3 in there. And I have to see if this is true. So 3 squared is 3 times 3, which is 9. And I've got negative 2 times 3. Negative 2 times 3 is a negative 6. And I've got a negative 15 here, right? So if I've got a 9 and I take away 6 and I take away another 15, that's a negative 12. Does negative 12 equal 0? No, it doesn't. So because that's the case here, this one doesn't work. I'm not even going to bother to check the second number on there. I'm just going to cross that out because they both have to work. They both have to work. All right, so let's try it for B. X squared minus 2, x minus 15 equals 0. So I'm going to plug in my 5. In this case, there's only one answer, so I'm going to plug it in for both. I've got 5 squared, which is 5 times 5, is 25. I got a negative 10 times 5, negative 2 times 5 is negative 10. and then I got a negative 15 here, equals 0. Then, so I got 25, I take away 10, that's 15, take away 15 more, and that's 0. 0 equals 0. So this looks pretty good. So we know that 5 is one of the answers. I could just circle that down, but remember I said we usually expect there to be 2 answers. So we know that 5 is good. 5 is one of them. So if I go on to C, well, 5 isn't either of the choices. So that can't be right. So it's likely going to be D. But let's check the last number there. That's the negative 3. So minus 2, just to be sure. So I'm going to plug in the negative 3 for each of my x's. I already know that the 5 works. The 5 works. So a negative 3 squared. I am multiplying everything in here. This is like parentheses. So everything in here is multiplied by itself. So this is like saying negative 3 times a negative 3. So a negative times a negative is, we know, a positive. 3 times 3 is 9. So this here becomes 9. And I've got a negative 2 times a negative 3. A negative times a negative is a positive. So that becomes a positive 6. And then I've still got my negative 15 equals 0. So I add them up. A 9 plus 6 is 15. Minus 15 equals 0. So 15 minus 15 is 0. 0 equals 0. So we know that one is correct as well.
Okay, so these types of problems is basically just a review of some algebra and just to kind of keep you on your toes. This negative is not being squared. If I was going to square the negative, or if I wanted to square the negative, I would need to put that entire thing in parentheses like that. That would give me where I would square the negative. And this is negative 3 times negative 3 gives me a positive 9. But here, kind of like the order of operations, I need to do this exponent before I take care of this negative. The negative is almost like it's being multiplied by a negative 1. So here, if I squared it, 3 squared is 9, but like we said, we did not square the negative, so this is actually going to give me a negative 9.
In this problem, we're going to use a ratio. We've got, for every 10 students that take underwater basket weaving, 8 students will pass. So we want to set that up like a fraction. If 8 pass over 10 total, and we're going to set that up to show how many students we expect to pass if there are 600 students enrolled. So in this case, you want to have the other side, you set the equal sign, you have the same setup as you had before. We have the number of the pass on top and then total number of students on the bottom. And we'll switch those up. So in this case, we know there's 600 total. How many are going to pass? Well, that's what we're trying to figure out. We don't know, so I'm going to use X as our number, right? It's just a variable. Since we have a fraction on the left side and fraction on the right side, we're going to cross multiply, right? So on one side, we have 600 times 8, that's 4,800. And then on this side, we have 10 times X. We want to get the X, which is the number that passed, or expected to pass by itself. We're going to divide both sides by 10. So on this side we have X, and if you're just dividing by 10, you can just knock a 0 off. So we have 480. 480 is C.
Okay, we have a circle that has a diameter of 12 meters. We have two circumference formulas on the reference sheet. One is going to be 2 times pi times the radius. And the radius is just half of the diameter, but we also have one that involves a diameter, and it's just pi times the diameter. So depending on the type of problem, if they give you one that gives the radius, we're going to use this formula. Since we know the diameter, we're just going to plug it in for D. So in this case, C is going to equal pi times 12, or in other words, 12 pi meters. So I think the reason why they put this on there is just to show you that sometimes your answer is going to be what we call left in terms of pi, where the actual symbol is part of our solution. This is the exact answer. I know a lot of times we're used to using 3.14 as pi, but really that's just an approximation. And so we don't really have any work to do. Our answer is going to be C, 12 pi meters.
In this problem, we need to find out the correct formula to figure out the area of this polygon. We don't actually have to find the area, we just need to get the formula. So first of all, we can figure out what kind of polygon this is. There's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 sides, so it's an octagon. So we are not given a actual formula for the area of an octagon. What you are, however, given is the formula for the area of a triangle. And the area of a triangle is equals 1/2 base times height. So we're going to work with that because what do we see? There's really 8 triangles here. There's really 8 of them. So we're going to take that and figure it out that way. One thing I do want to point out, this here is the base. Note that this dotted line is the height. This little box tells you it's a 90-degree angle. It's a right angle between the height and the base. That's always true in these formulas. The base and the height are always going to meet at a 90-degree angle. Don't think that this is the height. This is one of the legs of the triangle. Always go with the height. So make sure that it's at a right degree or a 90-degree angle or a right triangle from the base. The base and the height are always perpendicular. So as I stated, there are 8 of these triangles in our area. So our area is equal to 8 times 1/2 base times height. We can distribute this 8. So 8 times 1/2 is 4. So area is equal to 4 times base times height. And that's your answer. C.
Okay, finding the area of a trapezoid. The area formula is one that is given to us. It's 1/2 base 1 plus base 2 times the height. And so we're looking up here, what's what? Well, this little dotted line with our little box here tells me that this is perpendicular because it forms a right angle to this side here, as well as this side here. So trapezoids, the bases are going to be the sides that are parallel to each other. And these sides clearly aren't parallel. We call these the legs. But as you can see, the legs are not used in our formula, so we don't need them. So now we just plug and chug. So 1/2, 12 plus 7 times 5. So 12 plus 7 is 19. And then I can just plug this in my calculator. 1/2 times 19 times 5 is going to give me 47.5. So that is our area of this trapezoid.
in this particular question, we don't actually have to do any calculations. It's just important to know your definitions of your different types of shapes. You want to practice those. This one, select the quadrilateral, which means there's 4 sides, that must possess the following characteristics. Opposite angles are congruent. Congruent is just a fancy way of saying equal. And diagonals are perpendicular. Perpendicular means it meets at a 90-degree angle. So we're looking for anything that does that. So the first one is parallelogram, which we've drawn here for you. Well, let's see, are the opposite angles congruent? Well, this is the opposite angles here. Those are the same, and these are the same. So these are the same here, and those are the same there. So it seems to pass the first one. But are the diagonals perpendicular? Well, if I tried to draw those diagonals, you can see that they meet at a sharp angle here and obtuse angle here. So they are not perpendicular, so it can't be that one. Next one's the trapezoid. The trapezoid is this one here. Are the opposite angles congruent? Well, here's this angle, and here's this one. They do not appear to be the same, right? This one and this one would be the same. This one and this one would be the same, but they're not the same on the opposite sides. So the trapezoid would not be correct. The third one, the rectangle, are the opposite angles congruent? Yes, actually they're all 90 degrees. So all of the opposite angles are congruent. But if we were to draw the diagonals, they are at an angle less than 90 degrees. So that is not going to pass the second test. The last one is our rhombus, which is like a diamond or a square. The opposite angles are congruent, and they do meet at a 90 degrees. So rhombus is the correct answer.
Okay, this is a pretty common problem, and you might have this type of diagram with lots of other types of questions. These 2 lines here, they tell us are parallel. So if you want to look up some more problems like this, it's going to be 2 lines and a transversal. This line here is what we call the transversal. And because these 2 lines are parallel, that's going to give us nice relationships with these angles that we've formed. And we formed 8, right? 1, 2, 3, 4, 5, 6, 7, 8. So what's going to happen here is every acute angle, so every angle up here that is less than 90, they're all going to equal 63 degrees. And there's angle pairs in here, so this angle here is going to be 63. These 2 angles we call vertical angles. Similarly, those 2 angles would be vertical to each other. So I know that this is going to be 63 and this is going to be 63. This angle and this angle are what we call corresponding angles because they're in a similar position. They correspond to each other. I could think of them as both being above the parallel lines, and they are both to the right of the transversal, so they're in similar positions. And there's lots of, there's 4 pairs of corresponding angles here. The angle that's right adjacent to the angle that was given, we call these 2 a linear pair because when they're next to each other, they form a line. And these 2 angles are going to be supplementary, which means their sum is 180. So if I take 180 and subtract what we know, we're going to find that what's left over is 117. And so that tells me that this angle is going to be 117. This angle is going to be 117 because of those vertical angles. This angle is also going to be 117. These 2 form a linear pair, those 2 form a linear pair. And so therefore D is going to equal 117 degrees as well. So all the obtuse angles up here are going to be equal to each other, and all the acute angles are going to be equal to each other.
In this problem, we're trying to find the distance from point A to point C. And we have a triangle here, and it's a right triangle. This little square tells you it's a 90-degree angle. And since we're trying to find this distance here, we know this leg is 5 miles and this leg is 12 miles. This leg is also known as the hypotenuse. And we're going to use the Pythagorean Theorem to find that. All right, so I'm going to list these. I'm going to say this is small a for this leg or this side. I'm going to call this one small b for this leg, and I'm going to call the hypotenuse small c. And that's what we're looking for. So if we use the Pythagorean Theorem, we know that a squared plus b squared is equal to c squared. So we just need to fill in these. I like to use a box, a squared. I just pull out the variable and leave an empty box there that I label, is equal to c squared. We know a is 5. We know that b is 12. So we can square 5. 5 times 5 is 25. And we can square 12, right? Which is 144. And that'll be our c squared. So if we add the 25 and 144, we get 169 is our c squared. That's this area, this line squared, this distance squared. But we don't want it squared, right? We want the square root of that. So you're going to find the square root of both sides, and you get c is equal to 13, which is answer A.
Okay, so we need to find the volume of this box, and we have 3 dimensions. I can call this the height, the width, maybe the depth, but we do have 3 dimensions, and those 3 dimensions we need to multiply together to get the volume of a box. So length times width times height, or whatever you want to call them. So this total length here is going to be b plus b, all right? So from one side to the other, we have 2b. And so I know that the volume is going to equal a times 2b times c. And if we clean that up, we usually put our numerals out front. This is just going to be 2a, b, c. Another way we could have done it is said, well, if this is a, then I know this is a as well. And if I just find the volume of this little box, and this is c, so a times b times c for this box, well, same thing here, a times b times c, abc plus abc gives me 2abc. So just another way to do it.
In this question, we're constructing a concrete driveway that's rectangular.
Okay, this problem is pretty straightforward, but they try to trip us up a little bit. So we're just going to break this down into its 2 parts. So I have a cylinder on the bottom and a cone on the top. And we do have those volume formulas in our reference sheet. So both of them have that same radius of r. And so if we look at the top, the volume of a cone is 1/3 the area of the base. Well, the base is a circle, so that's going to be pi r squared, and then times the height. And the volume of a cylinder is just the area of the base, which is a circle, pi r squared, and then times the height. Well, the height here is a capital H, and that's where they want to trip us up, because capital is not the same as lowercase, therefore they are not like terms. So if we add those together, 1/3 pi r squared little h plus pi r squared capital H. This is the volume of the combines.
In this problem, we're dealing with probability. We've got 5 purple balls, 9 green balls, and 2 black balls. The first thing I want to do is find out how many balls we have total. So there's 5 purple, 9 green, and 2 black, right? So that's 9, 14, 15, 16. So there's 16 total. The next thing that I want to notice is that this says without replacement. That's an important term. In these probability problems, always look to find out if something's with replacement or without replacement. The difference being is without replacement means we're going to draw one of the balls and then we don't put it back. We just draw the next ball without replacing the first ball. With replacement would be we draw the first ball, see what color it is, put it back, and then draw the second ball. You're going to see where that makes a difference in a moment. So the first thing is, what is the odds, or what are the probability of drawing a purple ball? So that's our first one. Well, the odds of that is, there's 5 purple balls, and there's 16 total. So the probability of that is 5 over 16. Then we need to figure out what are the probability of drawing a green ball. Well, we know that there's 9 green balls, but they've drawn 1 ball out already. Let's say it was purple. So there's only 15 balls left. That's why the without replacement is important. If it's with replacement, then you would keep that as 16. So we could just multiply straight across. Remember, when you're multiplying fractions, you do not need a common denominator. You just multiply straight across. Or let's try and reduce it some on the front end. We've got a 5 here and a 15 there. I know 5 goes into 15 3 times. So 5 goes into 5 1 time. 5 goes into 5, it goes into 15 3 times. So I reduce that there. And then I see a 9 here and a 3 here, so I know I can reduce it further. 3 goes into 3 1 time, and 3 goes into 9 3 times. All we're doing is some reducing of these fractions. You can do this at the end, or you can do it on the front end. So now we go 1 times 3 is 3. We have 16 times 1 is 16. So 3/16, which is D.
Okay, what is the median of the number of student-owned telephones indicated in the chart? Well, the median is sometimes referred to as the 50th percentile. It's right in the middle. Okay, so what we can do is look at our chart and just think of have a running total going. Well, starting with 0, that accounts for 5%. And then if we look at the people with 1 phone combined, that is now accounting for 45%. All right. If we move up to 2, that is now accounting for 80% of the telephones or of the students. So what that tells us is after we stop looking at the people that have 1 phone and we start getting into the number of people that have 2 phones, that will include the 50th percentile. We're starting at, right after 45, and then we're going to go up to 80. So the 50th percentile will be found in the number of people that have 2 phones.
In this next problem, we know that there are drinks, sandwiches, and sides to choose from. So we know that there's 8 drink choices, and there's 4 sides, and there's 6 sandwiches. All we need to do is multiply those options together. 8 times 4 times 6 is 192. It's 192 options.
Okay, the Smiths have 5 children. So what I'm gonna do is give myself 5 spaces to put those kids. Okay, so the range of their ages is 7 years. Well, we can't really do anything with that right off the bat because we don't know any of their ages. They have twins that are 3 years old, okay, but we don't know if they have kids younger than 3. We don't know, if all of them are older, so we don't know where to put those kids in our spaces. We're gonna just be putting them in order from youngest to oldest. The median age of the children is 6. Okay, we can do something with that. The median is the middle, so I'm gonna put that 6 right there in the middle. And then now we can go back and say, well, if we know they have twins that are 3, we do have 2 spaces to the left of the 6, so we're gonna put those twins there. All right, now we can go back to the previous sentence and use the fact that we know the range is 7 years. The range we can calculate by doing high minus low, or in this case, if we wanted to find the oldest kid, we could just add 7 to the youngest. So I know that the oldest kid is 10, which means the kid that's in this spot, well, maybe they have more than one twin. So the kids could be 6, 7, 8, 9, or 10. We could have 10-year-old twins. So 6, 7, 8, 9, and 10 all could fit into that spot of the second to oldest child. So the only answer that would work would be B.
In this problem, we're going to need to figure out which of the measures of central tendency, which there's 4 options here, did the company use when they said that their car gas mileage is 42 miles per gallon. The first thing we need to do is to figure out the miles per gallon for each of these cars, right? So you're going to do that by taking the miles driven and divided by the gallons. So 312 divided by 8, and that gives us the first one, which is 39. And then the next one, we have 320 divided by 8 is 40. Like that, a little better than 39. And the next one, and we have 246 divided by 6 is 41. And the next one is 294 divided by 7 is 42. And the last one again is 294 divided by 7, so we don't even have to do the math on that one, we know what it is. All right, so we've calculated the miles per gallon for each of these cars. Let's figure out the mean. The mean just means the average. The average means we're going to add them up. So let's add all of those up. So 39 plus 40 plus 41 plus 42 plus 42. And that gives me 204. And to find the average, we take the total and we divide by the number. So divide by 5, and that gives us 40.8. So 40.8 is the mean, which is not going to be 42 miles per gallon. Let's look at the median next for a moment. To find the median, we're looking at the one directly in the middle. So to find that, you're going to want to line them up, your MPGs, from smallest to largest in order. Well, we're lucky it actually works out that way in this. If not, you would need to rearrange them. We're also lucky that there's an odd number. Since there's an odd number, we just look at the one in the middle. There's 2 on top, 2 to the bottom, 41. That's the median, 41. 41 is not 42, so that's not the one they're looking at. Had there been an even number, you would take the 2 in the middle, add them together, and divide by 2, which is just finding the average of the 2. All right, and finally, not finally, but the next is the mode. The mode is which one occurs most often. So we only have 139, we only have 140, we only have 41, but we have 2 42s. And that looks pretty good. Standard deviation is just going to talk about how spread out the data is. Well, this is not going to be anywhere near 42 spread out. Standard deviation you'll see in later problems, but in this case, mode's the correct answer.
Okay, so for this problem, we're going to find our mean, median, and mode and see which one is the smallest. We don't need to worry about standard deviation. You're not going to have a problem. That's definitely not one of the formulas that is on the reference sheet, so we won't need to calculate a standard deviation by hand. So let's start looking at the mean. The mean is just the sum of all of our numbers divided by how many of them there are. So we have 14 plus 6 plus 2 plus 5 plus 2 plus 1. That's going to give us 30. So we have 6 numbers. So 30 divided by 6 gives me 5. And so this is our mean. To find the median, we need to put it in order. So I'm going to do 1, 2, we have another 2, 5, 6, and then 14. So one thing we note is the median is the middle, but when we have an even number, we don't have a middle number. So we're going to look at the middle 2 and take the mean of them. So 2 plus 5 divided by 2. That gives us 7 divided by 2 is going to be 3.5. And so this is our median. And then the mode is going to be the number that occurs the most. So if we look back here, we notice there are 2 2s. That is the only number that we have more than one of. So that's going to be our mode. So to find the smallest number, we're just looking at 5, 3.5, and 2. And I'm going to go with 2 is what I would choose if I'm trying to attract more people to move there.
In this problem, we're trying to determine the probability of someone scoring above 115 on a test. So we have this normal distribution. This bell-shaped curve is known as a normal distribution, and the important thing to know is that under the curve is 100% of the data. So 100% would be everything under the curve, or you could say it adds up to a 1. Either way you can do it. If you want to say 1 is a whole, then you could do it that way. The other thing to know is that it's completely symmetrical. In other words, everything to the left of the middle is exactly the same as to the right. So half of it is on the left, half is on the right. That's important to know. We're given a mean of 100. And then we're given the mean plus 1, well, our standard deviation, plus 1 standard deviation. So our standard deviation in this case we're told is 15. So if we go mean plus 1, that would be 100 plus 15. This point here is 115. And then this would be the mean of 100 plus 2 standard deviations, which would be 30. So this would be 130 and 145 and so on. And then this would be, to the left, would be subtracting 15 each time because of the standard deviation. So our question is asking us what is the probability of scoring above 115? So we're looking for the area above 115. So this orange area here is what we're looking for, above 115. Well, we're given some percentages, and we're told that the area from here to here is 68%. Right? So we know that that's 68%. So if we know that the whole amount is 100%, and this area here that's blue, I'm going to make it blue, is 68%, then we can just take this chunk out, because we know those folks scored, those are some of the folks that scored below 115. Let's go ahead and remove those. So I can take 100%, the total, and take out the 68%, right? So we got 100 minus 68, and that leaves us 32. So 32% is still left in this graph. Well, that's this part and this part. But we don't want this part here, do we? This part here is even lower than this part. They did not score above 115. So we have to remove this part as well. What do we know about this part? Well, this part is exactly the same size as the part that I've colored in orange. The reason being is we know it's a mirror image. It's symmetrical. So whatever this part is, this part's the same. So we could take our 32 and divide by 2. So we can take our 32 and divide it exactly in half, and that gives us 16. So we know we have 16% here and 16% here. And 16% is the correct answer.
Okay, so we have another empirical rule problem, and our mean is still 100, our standard deviation is still 15, so each increment is going to go up by 15 to the right and down by 15 on the left. And so I've shaded the part that they're asking us for, just to find this area between the 115 and 130, so in between 1 and 2 standard deviations. And we know that between one standard deviation, if I go up and down one standard deviation, that gives me 68%. And then if I go up and down 2 standard deviations, that's going to give me 95%. Okay, because the curve is symmetric, I know I could cut it right down the middle and say, okay, well, if 68% is between one standard deviation, that means 34% is down here, and then 34% is on the right of the mean. We can do that similarly if we take the 95% and we can figure out just from, down here, from the mean up to the second standard deviation, that's going to give me half of the 95. So that's going to be 47.5% above the mean, and then 47.5% below the mean to the 2 standard deviations away from the mean that way as well. So if I know that from here to here I have 47.5, but from here to here I only have 34, then if I just take that away, that leaves 13.5%.
In this problem, we need to determine the probability that someone scores less than 100. And again, 100% is the whole area under the curve into the empirical rule. This is a normally distributed curve. We're told that the mean is 100, so that's right here in the middle. So if that's the case, we divide this in half. What's the probability of somebody scoring less than 100? That would be everybody on this side. And if it's completely symmetrical, like it should be, or if this is not normally distributed, it wouldn't be symmetrical, but because it is, half of the data falls to the left of 100. So 100 divided by 2 would be 50. So 50% is.
Okay, this last problem is kind of a two-part problem. We need to first find the area that is above 130. And so that 130 is our 2 standard deviation mark. So we know from the empirical rule that within 2 standard deviations is going to give us 95% of all of our data. And because the bell curve is symmetric, I know that this area here plus that area there will give us the remaining 5%. And since they're equal to each other, then we know that down here we have 2.5%, and similarly we have 2.5% on the left. So what we need to do now is just find out what is 2.5% of our population. So I have 0.025, that's my 2.5% as a decimal, and I just need to multiply that by 750 students. And so this gives us 18.8, and so that's going to be approximately 19 people.
In this problem, we're trying to find out which of these applies to this set of numbers. Okay, so we use this list of numbers to find out the following statements to see if they're true. So is the mode greater than the median is less than the mode, mean is not one of the numbers listed, or the mean, median, mode are the same number. So let's find those out. So first of all, let's find the mean. Mean is the same thing as the average. So we're going to add up the numbers, and I've already done that for you. They add up to 65. And then we divide it by the number that we have. There's 13 of these. I put n equals 13. So 65 divided by 13 is 5. So the mean in this case is 5. So let's look at the median. The median is going to be the number exactly in the middle, like the median in a row. There are 13 numbers here, which is an odd number, so that helps us find the middle. If it was an even number, we take the 2 in the middle, add them together, and divide by 2. But in this case, we just need to get the one in the middle. So it's 1, 2, 3, 4, 5, 6, 7. And then this number is in the middle, and then 1, 2, 3, 4. There's 1, 2, 3, 4, 5 on this side. Wait a minute. 1, 2, 3, 4, 5, 6, 7. I circled the wrong one. I apologize. And then there's 1, so there's 6 on this side, and then 1, 2, 3, 4, 5, 6 on this side. So each of these have 6, and the middle one is the 5 right in the middle. So that's 5. And then the next thing we need to know is what's the mode. That's the number that occurs the most often. There's only 1 1. There's 2 2s. There's only 1 3, 1 4. There's 3 5s, 1 6, 1 7, 2 8s, and 1 9. This number 5 occurs the most. That's the mode. That would be 5, and that means the mean is 5, the median is 5, and the mode's 5, so D is correct. The mean, median, mode are the same number.
We thank you for watching this video, and we hope that it was informative. And if you do still have any questions, please email us at asc@daytonastate.edu or go to our website, daytonastate.edu/asc, where you can start a live